The Constitution of India, Preamble. We, the people of India, having solemnly resolved to constitute India into a sovereign, socialist, secular, democratic republic and to secure to all its citizens justice, social, economic and political, liberty of thought, expression, belief, faith and worship, equality of status and of opportunity, and to promote among them all fraternity, assuring the dignity of the individual and the unity and integrity of the nation. In our Constituent Assembly, this 26th day of November 1949, do hereby adopt, enact and give to ourselves this Constitution.
Hello students, welcome back. It's for the first time we are celebrating Onam the new way, isn't it? Hope the celebrations went on nicely. So let's start our chapter.
So shall we begin our class? In the last class we have discussed on distance, displacement, velocity, acceleration, first equation of motion, etc. Isn't it? So today we will be discussing how to draw a graph. Okay, how to draw a graph. Mainly we will be focusing on two graphs, position time graph and velocity time graph. Okay, so first one is position time graph. Position time graph. Okay, so what is a position time graph? A graph plotted with time along the x-axis and position along the y-axis is known as a position time graph. Okay, so once again, a graph plotted with time along the x-axis and position along the y-axis is known as a position time graph. Look here. Here, this horizontal line is the x-axis and vertical line is the y-axis. Okay, so what will be marked along the x-axis? Time. Okay, time is marked along the x-axis and unit of time is second. And what will be marked along the y-axis? Position. Okay, position is marked along the y-axis. Unit of position is meter. And what will you call this point where the two axes meet? It is the origin. Okay, origin. Okay, so in position time graph, always time is marked along the x-axis and position is marked along the y-axis. Okay, so now we will study how to draw a graph in a graph paper. You have studied how to draw a graph in maths, isn't it? Bar diagram and all you have studied. So now we will be drawing position time graph. Okay, so now take your graph paper and write the question. Draw the position time graph for the following data. So here time and position of the object is given. Time 0, position 0, 1, 2, 2, 4, 3, 6, 4, 8, 5, 10, 6, 12. So, shall we draw the graph? Look at the values. Okay, time and position is given and first we can draw the x-axis and y-axis. Okay. Okay, x-axis, next. So now we can mark the x-axis and y-axis. So here this is the x-axis and this is the y-axis. Okay, and what will you call the meeting point? It is known as the origin. Okay, now look at the values. What is marked along the x-axis? Time is marked along the x-axis. So you have to write here time. And what is the unit of time? Second. Okay, and what is marked along the y-axis? Position. Position. What is the unit of position? Meter. Okay, so you got time and position. Now you have to look at the values. Okay, and the values is of time is 0, 1, 2, 3, 4, 5, 6. So how can you take the scale? So you can write the scale here at the top. Scale. Okay, so along x-axis, 1 centimeter is equal to 1 centimeter is equal to values നോക്കുക കേട്ടോ. അപ്പോൾ 0, 1, 2, 3, 4 1 വേരിയേഷൻ ആണ്. So you can write 1 centimeter is equal to 1 second. Okay, അപ്പോൾ 1ന്റെ വേരിയേഷൻ ആണ് നമ്മൾ എടുക്കുന്നത്. So and along y-axis, and what is taken along y-axis? Position. So 1 centimeter is equal to, look at the values position, 0, 2, 4, 6, 8, 10, 12. It is multiples of 2, isn't it? So you can take the scale as 1 centimeter is equal to 2 meter. Okay, 2 meter. Okay, so shall we mark the points? Okay, so here you can write 1, this is 2, 3, 4, 5, 6, 7. 3 mark here. And position. Again, no need to mark 0. Okay, already we have marked 0 at the meeting point. So you don't have to write 0 again. Next, what you have to write? 2. So here, this dark line. 2, 4, 6, 8, 10, 12, 14. ഒരെണ്ണം എക്സ്ട്രാ ഇരുന്നോട്ടെ. Okay, so now you can mark the points. See the first value 0, 0. Time 0, position 0. So where you will mark? This is the point. Okay, so just put a dot here. Okay, next look at the value 1, 2. So this is 1, 2. അപ്പോൾ ഇത് രണ്ടും കൂടെ മീറ്റ് ചെയ്യണ ഈ പർട്ടിക്കുലർ പോയിന്റ്. നെക്സ്റ്റ് ഇസ് 2, 4. എവിടെ മാർക്ക് ചെയ്യും? ഈ 2ഉം 4ഉം കൂടെ മീറ്റ് ചെയ്യണ ഈ പർട്ടിക്കുലർ പോയിന്റ്. ഓക്കെ, സോ യു ക്യാൻ മാർക്ക് ഹിയർ 4. ഓക്കെ, 2, 4. നെക്സ്റ്റ് ഇസ് 3, 6. 3, 6. So you can mark here 3, 6. Okay, next is 4, 8. അപ്പോൾ ഈ 4ഉം ഈ 8ൻ്റെയും ആ ഒരു പോർഷൻ. So you can mark here 4, 8. Okay, next is 5, 10. So 5, 10. You can mark here 5, 10. Okay, and last one is 6, 12. 6, this is 12. മനസ്സിലായല്ലോ മാർക്ക് ചെയ്യാൻ അല്ലേ? ഈ 6 പോണതും ഈ 12ൻ്റെയും ആ മീറ്റിംഗ് പോയിന്റിലാണ് യു ഹാവ് ടു മാർക്ക്. 6, 12. Okay, so you got the point. Next, what you have to do? You have to join these points. So how will you join these points? You can take this line and you can draw this line like this. Join all these points using your scale. Okay, see, what is the shape of this graph? This is called an inclined straight line. Okay, so the shape of the graph is an inclined straight line. Is it clear? So looking at the values itself, you can understand whether that object is moving in uniform motion or non-uniform motion. Okay, see, look at the values. Here position and time is given and equal ആയിട്ടാണ് അത് മൂവ് ചെയ്യണത് അല്ലേ? 2, 4, 6, 8, 10. Equal ആയിട്ടാണ് മൂവ് ചെയ്യുന്നത്. So we can tell that object is moving in uniform motion. Okay, so tell me, what will be the shape of the graph if the object is moving in uniform motion? If the object is moving in uniform motion, it will be an inclined straight line. Okay, it is an inclined straight line. Inclined straight line പറഞ്ഞാൽ എന്താണ്? ഇങ്ങനെ ചെരിഞ്ഞിട്ട്. Okay, so did you understand how to draw a position time graph? Okay, so now we can draw one more graph, position time graph. Look at the values. Time 0, position 0, 2 seconds, 5 meter, 4 seconds, 15 meter, 6 seconds, 20 meter, 8 seconds and 35 meter. So we can draw the graph. Okay, so now we can mark the points, mark the axis. So this is the x-axis and this is the y-axis. Okay, so what is taken along x-axis? We are taking time along the x-axis. So time, unit of time is second, and what is taken along the y-axis? Position. Position. And what is the unit of position? Meter. Okay, so now we can mark the points. So what will you call this point? Meeting point, origin. So 0. Okay, next here, how can we take the scale? See here, 2, 4, 6, 8. Okay, so we can write the scale like this. Scale, x-axis, 1 centimeter. Instead of 1 centimeter, we can take 2 centimeter. Okay. Okay. Can take 2 centimeter is equal to 2 seconds. Okay. Since time is 0, 2, 4, 6, 8. Next, along y-axis. Y-axis again we can write 2. 2 centimeter is equal to 5 meter. Is it clear? So shall we mark the points? 0, this is 2. അപ്പോൾ ശ്രദ്ധിക്കേണ്ടത് ഇവിടെ 1 സെന്റിമീറ്റർ അല്ല 2 സെന്റിമീറ്റർ. അപ്പോൾ രണ്ടാമത്തെ ഡാർക്ക് ലൈൻ. ഓക്കെ, സോ 2, then 4, 6, 8, 10. Okay, like this we can mark 2, 4, 6, 8, 10. ഓക്കെ, ഇവിടെ നമ്മൾ 2 സെന്റിമീറ്റർ ആണ് എടുത്തിരിക്കുന്നത്. ഇനി y ആക്സിസിൽ നോക്കുക, അതേപോലെ 2 സെന്റിമീറ്റർ ഇസ് ഈക്വൽ ടു 5 മീറ്റർ. സോ അഗെയിൻ ദിസ് ഇസ് 5, 10, 15, 20, 25, 30. Okay, then this is 35. Is it clear? So we can mark 0, 0. Where you will be marking 0, 0? Here, 0, 0. Okay, we can mark here 0, 0. Next is 2, 5. 2, 5. Here we can mark 2, 5. Okay, then 4, 15. 4, 15. 4 ഉം 15 ഉം കൂടെ മീറ്റ് ചെയ്യണ പോയിന്റ്. Here you can mark 4, 15. Then 6, 20. 6 നോക്കുക, 20യുടെ നേരെ. So 6, 20. Okay, 6, 20. Then 8, 35. 8 ഇതാണ് ലൈന്, ഇങ്ങനെ പോയി 35ൻ്റെ അവിടെ. Okay, 8, 35. Next, what you have to do? You have to join the points. Is it moving in uniform motion? No, the values are different, isn't it? The difference are different. So 0, 5. then 15. It is different. So you can join the points. So here we can mark the points. Okay, next again you mark these 2 points. Now tell me, is it a straight line? No, isn't it? It is changing. It is not an inclined straight line. So from this we can conclude that the position time graph of an object moving with non-uniform motion will not be a straight line, or it does not have a particular shape. Okay, non-uniform motion ആണെങ്കിൽ ആ ഒബ്ജക്റ്റിന് ഒരു പെർട്ടിക്കുലർ ഷേപ്പ് ഉണ്ടാവില്ല. ഇത് സ്ട്രെയിറ്റ് ലൈൻ പാരലലും അല്ല, ഇൻക്ലൈൻഡ് ലൈനും അല്ല, അല്ലേ? അപ്പോൾ വാല്യൂസ് മാറുന്നതനുസരിച്ചിട്ട് the shape of the graph also changes. Is it clear? Yes, look at this graph, position time graph. Okay, so here I am just marking the points 210, 420, 630, 840 and 1050. Okay, you are getting an inclined straight line. Okay, from this graph we can find out the position of an object at a particular time. Okay, we can find out the position of an object at a particular time. For example, you have to find out the position at the time 7 second. അതായത് 6ന്റെയും 8ന്റെയും നമ്മൾ മാർക്ക് ചെയ്തിട്ടുണ്ട്. 7 സെക്കൻഡ് ആയിരുന്നപ്പോൾ ആ ഒബ്ജക്റ്റിന്റെ പൊസിഷൻ എവിടെയായിരുന്നു എന്ന് കാണണം. ഓക്കെ, അപ്പോൾ എന്ത് ചെയ്യണം? നമുക്കറിയാം 6ന്റെയും 8ന്റെയും ഇടയിലുള്ള ഡാർക്ക് ലൈൻ, ദാറ്റ് ഈസ് ദ 7. Isn't it? അപ്പോൾ ഇവിടെ 7 കറക്റ്റായിട്ട് ഗ്രാഫിൽ നോക്കുക. ഞാൻ ഗ്രാഫിൽ നോക്കുക. എന്നിട്ട് ഇവിടുന്ന് സ്കെയിൽ വെച്ചിട്ട് ഡോട്ടഡ് ലൈൻസ് വരയ്ക്കുക. ഓക്കെ, 7 സെക്കൻഡ് ആൻഡ് ഇറ്റ് ഷുഡ് ടച്ച് ഹിയർ. ഓക്കെ, ഇത് ടച്ച് ചെയ്യുക. ഈ പോയിന്റ് എത്രയാണോ നോക്കുക, അവിടെ അതായിരിക്കും ആ ഒബ്ജക്റ്റിൻ്റെ പൊസിഷൻ. ഇത് 30യുടെയും 40യുടെയും ഇടയിലാണ്. സോ ഇറ്റ് ഈസ് 35. So like this method or through this way we can find out the position of an object at a particular time. So what is the position of an object at 7 second? It is 35 meter. Is it clear? Or tell me the position of an object at 3 seconds. 3 seconds പറയുമ്പോൾ ഇവിടെ വരും 3. അപ്പോൾ നമുക്ക് ഇതുപോലെ തന്നെ we have to put dotted lines 3 and it should touch here. So it will be 15 meter. Okay, through this method we can find out the position of an object at a particular time. Is it clear? So the next topic is velocity time graph. Okay, velocity time graph. So can you tell me what is a velocity time graph? A graph plotted with time along the x-axis and velocity along the y-axis is called a velocity time graph. Okay, so a graph plotted with time along the x-axis and velocity along the y-axis. See here. This is the x-axis, y-axis, meeting point is the origin. So here we will be taking time along the x-axis. So always keep in mind time is taken along the x-axis. Is it clear? And what is taken along the y-axis? Here it is velocity. Velocity is taken along the y-axis. And what is the unit of velocity? It is meter per second. Okay, so time is taken along the x-axis and velocity is taken along the y-axis. Such a graph is known as a velocity time graph. Okay, so shall we draw a graph? Take down the values. So now write down the question. Draw the velocity time graph for the following data. So here time and velocity is given. Time 0, velocity 10. Time 2, velocity 10, 4, 10, 6, 10, 8, 10 and 10 second, it is 10 meter per second. Okay, look at the values here. The velocity is same, isn't it? So here we can tell the object is moving with uniform velocity. Okay, the object is moving with uniform velocity. So shall we draw the graph? Okay, so now we can mark the x-axis and y-axis. X-axis, y-axis. Okay, so what is taken along the x-axis? Time. So you can write time is taken along the x-axis, and what is taken along the y-axis? Velocity. And what is the unit of velocity? Meter per second. Okay, now what you have to do? You have to write the scale. Scale along x-axis, 1 centimeter is equal to, x-axis it's multiples of 2. So you can write 2 seconds. Okay, and along y-axis, 1 centimeter is equal to, you can take 2 meter. Okay, 2 meter. So here, based on the scale, you have to mark the points. Okay, so see here how you will write. What will you call this meeting point? It is the origin. And x-axis, it is 1 centimeter is equal to 2 seconds. So it is multiples of 2. So the first dark line is 2, 4, 6, 8, 10, 12. Okay. So like this way, ഇങ്ങനെയല്ല നിങ്ങൾക്ക് ഇനി 2 സെന്റിമീറ്റർ വെച്ച് എടുക്കുകയാണെങ്കിലും എഴുതാം. നമ്മൾ ഓരോരോ ലൈൻ വിട്ടിട്ട് എഴുതുകയാണെന്ന് ഇരിക്കട്ടെ. Okay, suppose you are taking the scale 2 centimeter. Like that also you can draw. Okay. Now y-axis 1 centimeter is equal to 2 meter. So this is 2, 4, 6, 8, 10. Okay, so we can mark the points. It is 0, 10. 0, 10, where you will mark? Just we will change the color. Okay. Okay. 0, 10. So you can mark it here. 0, 10. Okay, next is 210. 210, again you can mark it here. Next is 410. Next is 610. Okay, 810. Then 1010. Like this way we can draw the graph. Okay, now you can join the points. You can join these lines. Just see the shape of the graph. It is a straight line parallel to the x-axis. Okay, it is a straight line parallel to the x-axis. So like this way we can draw the graph. Okay, so tell me what will be the shape of the velocity time graph of an object moving with uniform velocity. If the object is moving with uniform velocity, it will be a straight line parallel to the x-axis. Okay, you can write. It is a straight line parallel to x-axis. Is it clear? It is a straight line parallel to the x-axis. So from this graph, we can find out the displacement of an object at a particular time. Okay, we can find out the displacement of an object at a particular time. For example, you have to find out the displacement of an object in the time 4 to 10 seconds. Okay, you have to find out the displacement of an object from 4 to 10 seconds. So here we are telling we have to find out the displacement of an object at the time 4 to 10 seconds. So what you have to do is you have to put dotted lines here. Okay, 4 noka. 4 in the dotted lines ee line vere touch cheyana vere ingane mark cheya. Ingane mark cheya. അതേപോലെ 10 ന്റെ അവിടെയും നിങ്ങൾക്ക് മാർക്ക് ചെയ്യാം. ഇങ്ങനെ ഡോട്ടഡ് ലൈൻസ് മാർക്ക് ചെയ്യാം. Okay, so like this way we can. So you are getting, no? So you got a portion, isn't it? So you have to find out the displacement in the portion here. Okay, so this is the velocity time graph of an object moving with uniform velocity. Okay, velocity time graph of an object moving with uniform velocity. Okay, so look at this graph. It is a straight line parallel to the x-axis. So from this graph, we can find out the displacement of an object at a particular time. Okay, so for example, you have to find out the displacement from the time 4 to 8 seconds. Okay, you have to find out the displacement from 4 to 8 seconds. So how will you find out? So what you have to do is you have to draw dotted lines. Okay, if 4 in the start here, it should touch here. Okay, so 4 to 8 seconds. 8, where is 8? So 4 to 8 seconds you have to mark. Okay, now you got a particular portion. Name it as P, Q, R, S. So we can find out the displacement of an object in the time 4 seconds to 8 seconds. Okay, so we have marked dotted lines. So what is the formula for velocity? Yes, velocity is equal to displacement by time. Okay, velocity is equal to displacement by time. Okay, so from this we can find out displacement, isn't it? Displacement is equal to velocity into time. Okay, displacement is equal to velocity into time. So you have to find out the displacement of the object from 4 seconds to 8 seconds. So here, how much is the velocity? Here the object is moving with uniform velocity, isn't it? So what is the velocity? It is 10 meter per second. So 10 into time. Here we have to calculate time. But our time is 4 to 8 seconds. So 4 to 8 seconds. So how will you calculate time? 8 minus 4. Okay, for 5 to 10 seconds 10 minus 5. Okay, അങ്ങനെ നിങ്ങൾ ടൈം കാൽക്കുലേറ്റ് ചെയ്യണം. So here it is 8 minus 4, 4. Okay, so the answer is 40 meter. Okay, so the displacement of the object in the time 4 to 8 seconds is 40 meter. Is it clear? This is the way to find out, this is the method to find out the displacement of an object from the velocity time graph of an object moving with uniform velocity. Now there is another method to find out the velocity. Okay, see here, what is this shape? PQRS, it's a rectangle, isn't it? PQRS is a rectangle. How will you find out the area of the rectangle? Area of the rectangle is equal to length into breadth. Okay, this is, what is length here? PQ is the length, isn't it? So PQ, area of rectangle ABCD is equal to length into breadth. That is, what is length? PQ. What is the length? 10. 10 into breadth represents time. What is this? 4 to 8 second? 4. So 10 into 4, which is again equal to 40 meter. Okay, so this is how you will find out the area, or you will find out the displacement of the object. Is it clear? Okay, now we will draw one more graph. Okay, we will draw one more velocity time graph. Now we will draw the velocity time graph for the following data. So note down the readings. What is that? Time 0, velocity 0. Time 1, velocity 10, 2, 20, 3, 30, 4, 40. Okay, so we will draw the graph. Okay. Okay, we can mark the x-axis and y-axis. It is a velocity time graph. Okay, and what will you call this point? The point where the two lines meet? It is the origin. So we can mark that 0. Okay, now look at the values. Time 0, 1, 2, 3, 4. Isn't it? So we can mark like that. Here it is. 1, 2, 3, 4. Okay, see here how I have marked here. 1 centimeter വിട്ടിട്ടാണോ മാർക്ക് ചെയ്തിരിക്കുന്നത്? അല്ല, 1 centimeter പറഞ്ഞാൽ രണ്ട് ഡാർക്ക് ലൈൻസ് തമ്മിലുള്ള ദൂരമാണ് 1 centimeter. ഇവിടെ ഒരെണ്ണം വിട്ടിട്ട് അടുത്തതാണ്. So I have marked it as 2 centimeter. Okay, so how will you write the scale? Scale x-axis 2 centimeter is equal to, look at the values, 1, 2, 3, 4. So we can write 1 second. And along y-axis, it is velocity, isn't it? 0, 10, 20, 30. Again I am taking 2 centimeter difference. So here we can write 10 centimeter. And here 20 centimeter, then 30 centimeter, and here 40 centimeter. So here again I have taken 2 centimeter distance. So y-axis 2 centimeter is equal to how much? 10, 20, 30, 40. It is multiples of 10. So we can write 10 meter per second. Okay, 10 meter per second. Okay, now we can mark the values. It is 0, 0. So 0 zeros we will be marking here. 0, 0. Then 1, 10. 1, 10. Then 2, 20. 2 and 20. So here 2, 20. Then 3, 30. This is 3 and this is 30. So 3, 30. Then 4, 40. 4 and this is 40. Okay, so you got the points, and what we have to do next? We have to join. We can join that line. Yes, see here you are getting a graph, isn't it? So can you tell me what is the shape of this graph? It is an inclined straight line. It is an inclined straight line. So what is the peculiarities of this graph? Look at the values. Here time and velocity is given. Is it moving with uniform velocity? No, here the velocity is changing, isn't it? 10, 20, 30, 40, the velocity is changing. So when the velocity changes, what takes place there? acceleration takes place. So we can tell here the object is moving with uniform acceleration. Okay, here the object is moving with uniform acceleration. So what will be the shape of the graph of an object moving with uniform acceleration? It will be an inclined straight line. Is it clear? From this graph also we can find out the displacement of the object. Okay, so that we will discuss later. So now tell me what all things we have discussed in this class. We have discussed about position time graph and how to find out the position of an object at a particular time. Okay, and what will be the shape of the position time graph for uniform motion? It will be an inclined straight line. Okay, now what will be the position if the object is in non-uniform motion? It does not have a particular shape. Is it clear? Next, we discussed on velocity time graph. What is the shape of the velocity time graph for uniform velocity? It is a straight line parallel to the x-axis. And what is the velocity time graph, or what is the shape of the velocity time graph for uniform acceleration? It is an inclined straight line. So my dear children, go through the graphs or draw the graphs carefully in the graph paper, and if you are having any doubts you can contact me. Okay, so that's all for today. See you in the next class with a new topic. Bye.